Welcome to Lesson 60, my Algebra 1 students. This officially marks the halfway point of the book. Once we finish this lesson, then you only have 60 more and you'll be done. Congratulations. So halfway through is awesome, and we're halfway through before the end of the semester. So that's awesome. So this is something that we've done before. We did this in Lesson 15 and we did this in Lesson 20. In Lesson 20, we learned about volume. So we're going to spend just a little bit more time on volume. We're going to talk about what we call geometric solids. So a geometric solid is basically any object that has height, depth, length. It has substance to it. It's not a piece of paper. It's a box or a can or a cylinder. There's tons. Our world is filled with geometric solids. But for the purpose of this lesson, I want you to think more about like wooden blocks that you might have played with as a child. You know, the cool ones that you could make all different, that were all different shapes. And, you know, you had the painted red legs that you could turn into bridges. And you had blocks that you could turn into ramps that were triangle shape. So you had a bunch of cool little wooden blocks to play with and build things with. So that's kind of what I want you to envision. So we have several different kinds. But the one that we are going to really talk about are the right geometric solids. And a right geometric solid simply means that the altitude or the height of the axis, and the axis is the center line of your shape, is at a 90-degree or a right angle to the base. That's all that means. So a right cylinder would be a cylinder that is perfectly straight up and down. And its faces here, the circles on the ends, are parallel to each other. Something that would not be would be like something like this that was slanted, because then the line here would not be at a right angle to the base, right? This is a more of an acute angle. Right? A right angle would have to be like this, but this is at an acute angle. So we are going to be working with solids and shapes that have a straight up and down 90-degree right angle to the base of the object. That's what we're looking for. All right? So first of all, let's talk about the different parts. So if we have let's say we have a cube or a like a pillar, like maybe on your front porch you have like one of these that holds up the roof on the front porch. Something that actually looks a little bit more square would be great. Something like that. And we know it's straight up and down. It has to be straight up and down, because if it wasn't straight up and down, it would not hold the roof up, right? So straight up and down would mean this right here, right? It's perpendicular to the base. It's a 90-degree angle right there. All right, so we have parts of this shape. And this edge right here, the up and down part, this edge, wherever the sides meet, we call that a lateral edge. All right, that has a name and it's called a lateral edge. Now, around the circumference, excuse me, or the edge around the top, around the main shape or the base shape, that's going to be called your perimeter, as usual. But we also call it the perimeter edge, because it goes all the way around right on the edge of your shape. Now the side, like this whole side right here, that is called a lateral face. Now I want to point out that a cylinder or a tube does not have a lateral edge. The whole way around is its lateral face, but a shape like a polygon, regular polygon, square, rectangular right prism has lateral faces, and this has 1, 2, 3, 4 lateral faces going all the way around. All right. So let's talk about the volume of prisms and cylinders. So for the volume of any of these right solids is always going to be, the volume is equal to the base times the height. So it could be a circular, or it could be a rectangular, it could be a pentagonal, it could be a hexagonal, it could have any shape whatsoever. The volume is going to be the base times the height. The lateral surface area, that means all of these lateral sides, lateral in Latin is sides, so it's the side area. So the lateral area is going to be equal to the perimeter of the base times the height. Okay? And then you have base area, which is whatever shape is on the bottom. Okay? That is the shape that is on the bottom. Total surface area is 2 times the base area plus the lateral surface area. We have discussed all of this before in lesson 20, but we're going to go over it one more time. Okay? All right, so we have a couple practice problems. Let's do them down here. We have a pentagonal prism, which looks something like this. All right, a little bit like that. And it is a prism. This base is 28 centimeters square. The height right here is 10 centimeters tall. In order to find, now this is 60.1, in order to find the volume, we are going to need the base times the height. So 28 centimeters square times 10 centimeters is going to equal 280 centimeters cubed. That's it. That's our volume. Easy peasy. They gave us this dimension and this dimension, and we just had to multiply them together. Done. Notice we have centimeters squared. Remember our exponents? Squared is an exponent, right? We have an exponent of 1 here. We multiply cm2 times cm1. We add the exponents together. That gives us cm3. This tells me that this is volume. If I see this written down somewhere, I know that's a volume measurement. If I see this written somewhere, I know that's an area measurement. And if I see this somewhere, I know that's a length. So when we multiply the area times the height or the length of something, it gives us the volume, which is what this says up here. All right, so now we have 60.2. Let's do 60.2 here. And we are told that we need to find the lateral surface area of a right prism whose bases are regular pentagons. So similar to this, it's a regular pentagon. I promise you they're all the same length because it's regular. Now, each one of these is 8. Okay. Each side is 8. and the height is 15, and this is meters. So we need to find the lateral surface area. So in order to find the lateral surface area, we need the perimeter of the base times the height. This is the same as the base. So we need to find, it's a pentagon, so there's going to be 1, 2, 3, 4, 5 edges. So we can say that the perimeter is going to equal 8 meters times 5. So that's going to be 40 meters around the edge. Now we just multiply this perimeter for our lateral surface area is going to be 40 meters times 15 meters, because that's the height here. So 40 times 15, that's going to be 600 meters, and we have meter 1 times meter 1. We add the two integers together and we get, or the two exponents together, we get meters squared. So that is how we would find the lateral surface area of this regular pentagonal prism. All right, regular means that all the sides are the same length. So that's why we could take 8 and multiply it times the 5 sides of a pentagon and get 40. And then we take that 40 and we multiply it by 15, which is the height, and we get 600 meters square. And that is just what is around here, okay? Just what is around the sides, because we were only looking for the lateral surface area. That's our LSA, which is right here. And guess what? That is all we have for lesson 60. So I will see you in lesson 61, and congratulations for making it through to lesson 60. You are halfway home. That's really a big deal, and I'm very proud of all of you. So I will see you in lesson 61 or on Thursday, whichever comes first.